very high because of the coherence property. Because of the coherence property of the waves, so the light wave or the laser light can travel longer distances because of the coherence property. Okay, so this normally you can draw these pictures incoherent wave how it looks, because the amplitude and phases will be different for different waves, but in the coherent waves the amplitude and phase will be exactly same whatever you observe here. Okay, and the color will be same for everything because it's a monochromatic light. These are the coherent waves, so that's why all the waves will travel in single direction without any deviation. Because if we have a random motion of waves normally, as we discussed in the wave optics, that is constructive and destructive interference will take place, so the amplitude will be cancelled or sometimes amplitude will be double. Okay, so that means the amplitude is increases, there's the constructive interference we set, and if the amplitude decreases or minimized, then we have a destructive interference. Is it? So here in the case of coherent waves, the waves are not superposing, and that means they are not overlapping each other. So that means you will never expect any diminishing of the amplitude. Okay, so that's why the laser light can travel and longer and longer under some kilometers of distance without any overlapping of the waves, because all waves are traveling in a single direction. That's why if they are traveling in a single direction, there is no any overlapping, there is no any superimposing, and there is no any constructive and destructive interference, a phenomena that will not occur in this. Okay, so that is what you have to understand, what is coherent and incoherent waves. Okay, just draw these diagrams. Yeah, and exactly everything should be kept in the same order in the coherent waves, and randomly you can draw it, that is incoherent. Okay, once you finish this, and please let me know. Yeah, fine, very good. Don't worry about the different colors of light, that is whatever the wavelengths, and draw it with the single color or whatever, but random, and this is the in order manner. That's the variation that you should show. Okay, don't rush to different colors of sketches. Clear? Okay, let's go. Yeah. Okay, fine. Okay, there are the two types of coherent waves. One is temporal coherence and spatial coherence. Okay, this question was asked very rarely. What are the different types of coherence property? Okay, so it was not asked previously, but maybe the examiner is very tough. Definitely will ask this kind of questions and types of coherence. Okay, So temporal coherence and spatial coherence. Okay. So normally when you discuss something about it's a coherent wave or coherent source, and immediately they will pose the question that is it a temporal coherence, is a spatial coherence. If coherent source or coherent wave, if it is maintaining the only temporal coherence is a coherent wave, or otherwise it has to maintain the two coherent properties, that is a temporal and spatial, both they have to maintain. What do you say? Is one is enough to say that the coherence, or two must be followed, temporal and as spatial? What do you say? Anyone? So coherence is classified into two types. One is temporal and spatial. So if the wave is two must be followed. Yes, you're right. So the wave is coherent means they have to follow the temporal as well as spatial coherence. If anything is does not match with that wave or a coherent source, so that means it is not the coherent wave. The temporal case and as well as the spatial case, and both should be followed. Then only that is the coherent wave. So temporal coherence means what? For example, temporal means only one thing we can remember. Take a one wave. Okay, temporal coherence means, so we are talking about means we are trying to understand in terms of time. So that's why let us consider only one wave. In the wave, then we consider only 2 points, A 1 point and B 1 point, and that wave or coherent wave or light wave is traveling along the positive x-axis, that is moving in the right direction, let us say. Okay, so we are trying to understand here the 2 points that are we are locating on the wave, that is A and B on the same wave. Now at the point of means what is the phase of the point A, and what is the phase at the point B? Okay, that we should mention what is the phase of the point A and phase of the point B. Then we should take into account that is what is the difference between the phase of the 2 points. Okay, so let us see here. Phi of A, phi means the phase. The phi of A is the phase of a point at any point. Phi of B is the phase of point B at any point of time. So for example, what is the phase? Actually what we discussed in the previous case. So phase means at any particular instant of time, at any particular instant of time, the oscillation or whatever the means the direction, the position of the particle is nothing but a phase. Are you remembering or not? Okay, at any particular instant of time, the position or oscillation of any point that you are locating on the particular wave, and that is called the phase of that particular point. Okay, so that phase, if you want to define it, the phase of the particular point A at particular instant of time t, and for example in this wave at maybe at 5 seconds you are saying that this is the phase of the A is something 90 degrees, and exactly after 10 seconds, and when the A point reaches to here, and exactly after 10 seconds, and if it is maintaining the same phase, that is a 90 degrees again phase angle, so after 15 seconds, so 5 to 10, 10 to 15, again the particle, if it maintains the again 90 degrees, so that means it is exactly maintaining the same phase difference or constant phase difference, we can say that. Okay, so whatever the point of location or point of oscillation and a particular wave, it has to maintain the equal phase difference. That you can say that is the constant phase difference or equal phase difference or zero phase difference we can consider. Okay, so now the 2 points that you can consider, A and B. So phi is equals to phi of A minus phi of B, the difference between the phase of the two waves. Okay, that difference that you can because the phi is independent of time of points A and B and said to be exhibit temporal coherence or longitudinal coherence, that you can normally we can say in that way. So this is the way, this is the this should be, that difference should be constant or zero. If the difference, yes, two must be difference should be zero or constant. So they have to maintain at each and every particular instant of time, otherwise it is not the temporal coherent wave. If they don't maintain that the points are not maintaining exactly the same phase difference, that we should not say it is a coherent wave. It is not following the temporal coherence property. Got it? So this is the thing. And while writing, if you have anything, doubts and all, just please let me know. Just write down the two different types of coherence property. So that is the temporal coherence and the spatial coherence. Temporal means is the time factor. Is related to the time factor. Is it? Okay, that's you can write temporal coherence and spatial coherence. Yeah, constant phase difference. It should be constant or zero. Yes, temporal. Yes, temporal means is a time related. But when you are talking about the temporal at any instant of time, not a time, don't confuse here. At any instant of time, the phase you are considering. At any instant of time, the phase you are considering. The difference between the phase at any particular instant of time, that is a constant phase. ఫేజ్ అనేది ఏంది మనం టైంలో మాట్లాడతాం టెంపరల్ అని మాట్లాడడానికి లేదు ఏదన్నా ఒక పర్టికులర్ టైంలో ఆ పొజిషన్ ఆఫ్ ద పార్టికల్ ని మనము ఫేజ్ అని అంటాం డిఫరెన్స్ అని ఎప్పుడు అంటాము ఒక పర్టికులర్ టైంలో ఒక ఫేజ్ ఆఫ్ ద పార్టికల్ తీసుకుంటాం ఇంకొక పర్టికులర్ టైంలో ఫేజ్ ఆఫ్ ద పార్టికల్ తీసుకుంటాం ఆ రెండింటి మధ్యన డిఫరెన్స్ ఎగ్జాక్ట్లీ కాన్స్టెంట్ ఉంది అనుకో అంటే ఎప్పుడు ఒక 30 degrees మెయింటైన్ చేస్తుంది లేదు 70 degrees మెయింటైన్ చేస్తుంది ఎవ్రీ టైం వేర్ ఎవర్ యూ కన్సిడర్ ఓకే then that is a constant phase difference antam ledu ante if there is no phase difference that is a zero phase difference so both should be same constant or zero but that should not be equal to temporal means is the time related I'm saying time related means particular time what is the phase at particular time what is the phase what is the difference are they maintaining the constant or zero that should be known is it clear Anjali okay okay guys please note down this temporal coherence and spatial coherence and then just write down what is temporal coherence. Particles, considered particles should have the same phase difference or same phase. Difference should be same. So whatever the phase that they can maintain, no problem. But the difference, whatever you are considering, one point to another point at particular time. Okay, if 5 seconds and 10 seconds, the particle is moving from A to B. So they have to maintain the constant phase. And the difference we have to consider. అంటే ఇది ఎగ్జాక్ట్ గా ఏ దగ్గర అదే ఉండాలి బి దగ్గర అదే ఉండాలి అంటే ఎస్ రెండు అదే ఉంటేనే కదా మనకు మెయింటైన్ అయ్యేది అదొకటి ఇదొకటి మెయింటైన్ ద సేమ్ ఫేజ్ దే హ్యావ్ టు మెయింటైన్ అంటే ద డిఫరెన్స్ షుడ్ బి సేమ్ ఫేజ్ డిఫరెన్స్ అని మాట్లాడుతున్నాం అదే సింగిల్ పాయింట్ తీసుకుందాం బి అనేది తీసుకోకుండా సింగిల్ పాయింట్ తీసుకుందాం ఏ అనే పాయింట్ దగ్గర ఎంత ఫేజ్ ఉందో ఆఫ్టర్ సమ్ టైమ్ అండ్ బి అనే పాయింట్ దగ్గరికి రీచ్ అయింది అనుకుందాం అంటే బి లేదు ఇక్కడ సో దట్ మీన్స్ ఇట్ హాస్ టు మెయింటైన్ ద సేమ్ ఫేజ్ ఇక్కడ ఎంత టైంలో ఎంత ఫేజ్ ఉందో మళ్ళీ బి దగ్గరికి వచ్చేసరికి అంతే ఫేజ్ మెయింటైన్ చేయాలి అప్పుడు కాన్స్టెంట్లీ the phase is going to be equal means at 5 seconds the phase difference and yes so that with the temporarily or with the time that they have to maintain the particle oscillation or position of the particle must be maintained yes okay just note down guys Radharam next okay fine just to take this difference we consider phi of a is the phase of point A any time maybe short answer question they may ask in this what is temporal coherence or what is spatial coherence sometimes okay anyway we must know what it should be coherence means Okay, done, guys. Let's go to further slide. Yeah, the spatial coherence. Okay, let us take the spatial coherence means here one particular point at any instant of time that we have considered in the previous case. But in this case, and let us take the two waves. Okay, so in this, when we consider the two waves, so the one wave is having the position of the particle is C, and the second wave is having the position of the particle is D. Okay, so the spatial coherence means whatever the separation between the two waves, the C point and D point, they must maintain the same phase on the two different waves. Okay, because the coherent waves, there are so many number of coherent waves are there, but each and every wave, because whatever you hear, if you see here in the picture, the whatever the point you consider on the each and every wave, they must maintain the exactly the same phase on each and every wave. Whatever you consider, if you have a bunch of waves that are traveling in the coherent with the coherent property. Okay, so that means each and every particle or each and every particle that we consider on the each particular wave at particular instant of time, and that should be maintained exactly the same phase difference, then only we can say the spatial coherence. Okay, so here you can consider the C point and D point, and the as usual two different points. And again, you can consider the difference between the 2 points, phase of the C particle and the phase of the D particle, and that is called as a spatial coherence or the transverse coherence. Normally, we consider it. Okay, so they have to maintain each and every wave, because in the previous case we considered the single wave, and in the single wave at any point of time, the position of the particle we considered and the different times. Okay, but now we are considering these uh, two waves and this one. Okay, just note down this, guys. Spatial coherence. Okay. Hello. Yeah. Nothing to confuse. The two waves you are taking, the phase of the particle here and the phase of the particle, the both particles should be maintain the same phase here. That's nothing to confuse. Single part. సింగిల్ వేవ్ తీసుకుంటే ఆ వేవ్ మీద ఎక్కడ చూస్ చేసుకున్నా సరే ఆ ఒక పాయింట్ నుంచి ఇంకొక పాయింట్ కి డిఫరెన్స్ షుడ్ బి సేమ్ ఉండాలి. ఇక్కడ రెండు వేవ్స్ తీసుకుంటాం, అక్కడ వన్ వేవ్ తీసుకుంటాం టెంపరల్ కోఆర్డినేట్స్ ఎక్స్ప్లెయిన్ చేసేటప్పుడు. బట్ ఎక్కడ తీసుకున్నా ద phase of the particle should be, I mean, whatever the difference between the two positions, if you are considering, the difference always must be maintained the zero or constant. It's nothing to be difficult here. ఒకటి పరిగెత్తినప్పుడు రాదా అలాగే. Okay. The points can be anywhere. Yeah, this is the previous slide. Consider 2 points anywhere. Yes, not a straight line. It's in the wave, whatever, because the particle, because it's a sine wave. If you consider the particle is oscillating in a particular direction, then only you can consider the phase. Okay, oscillations that you have to consider the positions. So not in a straight line, but anyway, because the temporal coherence means single point, single wave that you're considering, and the spatial, you can consider the two waves or three waves. It's not a single straight line. It's just moving in a positive direction. Shown like that straight line. There is a straight line. If this is what you are saying, the line. That means all the points located at this particular regions are the same, or I mean the positions will be same. That's what I mentioned here. Is it? Yeah. Let us discuss this atomic excitation and energy states. Okay. Here, laser produces a highly directional and high intensity with a narrow frequency range. That's already we know that. And here, in an atom, electron in a ground state is stable and moves continuously in its orbit without radiating energy. Okay. Uh, this is already we know that as a ground state is stable and moves continuously without radiating energy. And when the electron receives amount of energy is equal to the difference of the energy of the ground state and of the excited state, it absorbs energy and jumps to the excited state. What do you understand here? For example, if we take any material and the material consists of, or the matter, whatever the material consists of, many number of atoms, and each atom consists of electrons, protons, and neutrons. So electrons are revolving around that atom. Is it or not? Okay, this is everybody knows. Okay, when you give some energy, basically when the electron is revolving around an atom, so it cannot, because according to the Bohr's radiation or excitation states, but whenever the energy is incident on the material, or if you give some external energy, okay, some kind of light or some kind of thermal energy or some kind of electrical energy or some kind of energy that you are supply to the material, then the electrons will absorb that energy. Electrons will absorb that energy and they can jump. Basically, electrons will be staying in the ground state. Electrons will be staying in the ground state, and when you give some energy externally, okay, then the electron will absorb that energy and jumps from ground state to excited state. And that energy, because whatever the energy, for example, 2 electron volts of energy that is absorbed by the electron, so that means electron will select the particular energy, because there are so many energy levels above the ground state. There are the infinite number of energy levels are there, infinite number of energy levels. So which energy state it has to occupy? So the electron will select the particular energy state. That energy difference is equal to the ground state and that particular energy state. Then that electron can jump to that particular energy. ఎందుకంటే మన దగ్గర చాలా ఎనర్జీ స్టేట్స్ చాలా ఇప్పుడు number of energy states ఉన్నాయంటే, so which energy state is suitable for us? That means how the energy is utilized to jump from ground state to excited state, that will be seen. Okay. It's clear or not? So that means electron jumps from, so as you know in the chemistry, the Bohr's idea. So that is electron jumps from energy level E1 to energy level E2. So that means E1 is the ground state, let us consider, and E2 is the excited state. So whatever the energy, that the photon energy incident on the electron, then the electron will absorb that energy and jumps to ground state to excited state. And how much time it will stay in the excited state? In 1 day, 2 days, and lifetime. Anybody? So if the electron jumps from ground state to excited state, How much time? Just for some time. Sometime అంటే ఎంతసేపు తీసుకోవచ్చు? Some time is nothing but 10 to the power of minus 8 seconds. Yeah, some seconds. Perfect. 10 to the power of minus 8 seconds only the electron can stay in the excited state, and immediately it loses the energy, and then it can come back. It can come back to ground state. Only the very short of time, the 10 to the power of minus 8 seconds only, it can stay there. Okay, just take the atomic excitation, how it is taking. So electrons are receiving the energy and jumping from ground state to excited state. That is due to the absorption. The amount of energy is amount of energy. The standard is absorbs. Yeah, I said 2 10 to the